Before we talk about scientific notation, I want to do a little review on evaluating exponents. So for instance, if I have 10 to the fourth power, that is basically 10 times 10 times 10 times 10, or 10,000, okay? And if you were to do a few of these, like say 10 to the second power, that's 10 times 10, or 100, or let's say 10 to the third power, that would be 1,000. Okay, you'll kind of see that the exponent is basically telling you how many zeros are going to be in your answer. Okay, so 10 to the second has 2 zeros, 10 to the third has 3 zeros. Now this is always going to be the case if you're working with a positive exponent. In all of these cases, the exponents are positive numbers, and so you're just going to be counting the number of zeros and will match the exponent that's given with the 1. Okay? Now if you have a negative exponent, say you've got a negative 2 exponent, how we would represent that as the following. So this would be basically 1/10 times 1/10. Okay, so 1/10 times 1/10 is going to be 1/100th. And if we were to write this as a decimal, that would be 0.01. So notice we don't have 2 zeros in this case. We do have 2 decimal places, though, if that helps. So we go 1, 2. But we're going to keep the decimal there. So 10 to the negative second power is 1/100th, or 0.01. Now we could do, say, 10 to the negative third, and again that would be 1/10 times 1/10 times 1/10, or 1/1000. And in decimal form that would be 0.001. Okay, so that's tenths, hundredths, thousandths place. So in this case we've got negative 3 exponent, but we only have 2 zeros before the 1. Okay, but there are 3 place values, if that helps. Okay, so that's just a little review of how to evaluate exponents, whether it's a positive exponent or a negative exponent. Now let's talk about scientific notation. So scientific notation uses powers of 10, whether it's positive or negative exponents, to represent really big numbers or really small numbers. And if you're a scientist, you're likely to use scientific notation quite a bit. And there might be other career fields that use it, but that's the one that I thought of right at this very minute. Anyway, so a number, let me give you an example of what scientific notation looks like. So you might have something like 6.2 times 10 to the third power. Okay, so this would be considered scientific notation. And what we would want to do, if we want to know like what that number is, we would convert it to standard notation. And basically what we're doing is we're going to be taking this 6.2 and we're going to multiply it by 1,000, because 1,000 has, 10 to the third power is 1,000, right? Okay, so really what we're doing is then if we take this by 1,000, and I'm showing you the long way, but we're going to do the shortcut way here in a minute, but just so you understand what's going on. This is 10 to the third power, which is 1,000. If we multiply this by 1,000, we're basically moving the decimal point, 6.2, to the right 3 places. So we're going to go 1, 2, 3, and that's going to become 6,200. okay? So 6.2 times 10 to the third power is really 6,200. And this would be in standard form. Okay? When it's written as a number times the power of 10 with an exponent, that is standard notation. This is, or excuse me, scientific notation. Scientific notation. When it's written without the times 10 to whatever exponent, then it's called a standard notation or standard form. So we're going to do some problems relating to scientific notation and standard notation. Now, let me just specify standard notation. This 6.2 was just an example, okay? But there are some rules that we need to follow when we're doing scientific notation. And so, for instance, in scientific notation, a number is equal to or greater than 1 and less than 10, okay? So it's equal to or greater than, so greater than or equal to 1, okay, but less than 10, okay? So, and here we have 6.2, that's greater than 1, but it's also less than 10. So basically we're going to have a number between 1, including 1, and anything less than 9. So it could be 9.9, but it would still count, but it just can't be 10. So it could be 4.271 times 10 to, like, say, the 7th, or 9.9999 times 10 to the negative 3rd. Okay, so but we cannot have say 14.3 times 10 to the 4th. Okay, this would not be proper scientific notation, because this part here is more than 10. I hope that makes sense. I hope I'm not making it more confusing. Okay, now let's go ahead and do some examples with positive exponents and negative exponents for scientific notation. So we're going to write, we're going to first start in scientific notation, and then we're going to convert to standard notation. So scientific notation, and then we'll go to standard notation. Okay? Alrighty, so let's say, we'll start with an easy one. Let's say we've got 4.5 times 10 to the third power, okay? So basically what we're doing, this 3 is telling us how many places we're going to move the decimal point. So we're going to move the decimal point 3 places to the right, all right? So positive exponent means we're going to the right. We're making the number bigger, okay? So if I write it over here, we're going to go 4.5, and I'm going to move it to the right, because really we're multiplying by 1,000. We're going to go 1, 2, 3. So I'm just going to add in some zeros. So my answer here is 4,500. So 4.5 times 10 to the third power equals 4,500. Let's do another one. Let's say we have 7.6 times 10 to the 5th power. Okay, so again, we're going to move the decimal place over 5 places. So we got 7.6, and I'm going to go 1, 2, 3, 4, 5. Just plug in some zeros, and that's going to be 760,000. Okay, pretty simple, let's look at some negative exponents. Let's go with 1.3 times 10 to the negative fourth. Okay, so I'm going to write my 1.3 here. Now instead of going to the right, moving the decimal over to the right, I'm going to move the decimal over to the left. Okay, so instead of going this way, I'm going to go this way, and I'm going to go 1, 2, 3, 4. That's where my decimal goes, and then I just plug in some zeros. And if I want to rewrite this to make it look neat, I've got 0.00013. That's tenths, hundredths, thousands, 10 thousandths, 100 thousandths. So it's 1300 thousandths. That's a really small number. But we can go even smaller. Let's say we have 8.45 times 10 to the negative seventh. So again, I'm going to go 8.45, and I want to go this way, so I'm going to go 7 in this direction. 1, 2, 3, 4, 5, 6, 7. Put my decimal there. And notice that I've got how many zeros here? I've got 1, 2, 3, 4, 5, 6 zeros. I'm not going to count this number 8 here as a 0 because my decimal was after the 8. Remember, in scientific notation, your number has to be equal to or larger than 1, but less than 10. So a little trick here is if your negative exponent is 7, you're really only going to add 1 less than 7, which is 6. So 6 zeros, and that's what we have, 1, 2, 3, 4, 5, 6. So our number is going to be 0.000000845. That's a really small number. And if you want to think of place value, tenths, hundredths, thousands, 10 thousandths, 100 thousandths, millions, 10 millions, 100 millions, billions. So this number is in the billions. That's a TH, billions. That tells you it's a decimal number. Okay, let's do one more. Let's say we have 1.04 times 10 to the negative, let's not go too crazy. Let's go negative 3. Go ahead and write out what you think the answer is. Okay, if you got this, you're on track. Because again, here was the decimal. We're going to go 3 in this direction to the left, so 1, 2, 3.00104.